Good day, ladies and gentlemen. Welcome back to our second series of the 5 minutes with R. So another request from y'all will be, what can R do? Right? So basically, the main idea of R statistic programming is to run statistics and data visualization. It is one of the most powerful statistical programming, which it's directly focused on statistics and data management. So in basic terms, what can R do? R can be used for a wide range of tasks, like including data manipulation, cleaning of your data, especially data that is huge and large in size, where sometimes even Microsoft Excel cannot load all the data in it. Yeah, Microsoft Excel have some limitation as in the number of rows and columns that can be loaded at a time. And secondly, it has a very large library of packages and functions add-ons to run statistical analysis and modeling of your data. And lastly, is one of the reason why I chose to use R statistic programming for my work will be the data visualization and reporting. Let me show you a very simple example. I've loaded up a data right here. It's called data one. So data one has a few columns right here. It's actually quite linked with each other. Number one is just a individual code identifier, and then it has week, day, depth, and turbidity. So I have a depth of bottom and surface, and day from Monday to Friday, Sunday, week 1 to 20. So let's start off by loading some packages that I need for this run. And I want to look at the data distribution of turbidity. I'll just load, and you can see that with just one simple script, we can load the histogram of the turbidity. And if I want to run some more normality check on the distributor of the data, then you can use a QQ norm. As you can see, the data is a little bit skewed out of a normality distribution. And when I look into sorry, right here, and you will see that the turbidity skewness 0.97, which is slightly positively skewed, as you can see right here, it's skewed at the positive based on this value. And when we run the Shapiro test, we found out that it is not normally distributed. So another example that I can show you will be looking into the square root. So I add another column into my data where I call it a square root of turbidity. And as you can see right here, one now, there's a third square root. If I were to run the histogram, you can see that it's more normally distributed as compared as prior. And we look at the curriculum, it's much normally expected nominal distribution. Skewness was within 0.5, which is well balanced. And with a Shapiro test, it shows that it was not significant different, which means the steric stability is normally distributed. Look at the graph, it's well nice bell curve. So if I want to look into the the difference between our turbidity square root by depth with bottom and surface, this I would like to do it based on a dependent test, or what we call it as repeated test lah, or dependent t-test. So since it is a normally distributed data. So before we start, we can also do some table generation of the numbers. You can see that the turbidity has the mean, standard deviation, the median, the P0 minimum, Q1, Q2 is the median, and this is a Q3 maximum, and the histogram that we saw earlier has been represented here as well. So another one will be, I try to organize the data into white, which means the bottom and the surface are now next to each other, and so they are considered as repeated tests. If I were to use a repeated test, and you can see that, okay, sorry, bottom, t-test, right, white, data one, white, outer sign. You can see that the result is the p-value is less than 0.01, which is significantly different. So now we know that using R, we can manipulate or change the data, or add some transformation, and as well as run some statistical analysis such as a normality test. The simple repeated test of t-test, per t-test. And then now the next one will be want to look into data visualization. We can visualize your data by looking into box plots. You can see here a nice box plot. If we zoom in, nice box plot between surface and bottom. And this is a basic base plot. If I want to look into more details, then I can generate it. And now here is a more detailed base plot using ggplot. And we can see here ggplot, bottom and surface. You can see the difference. Much better, cleaner. So using another package of ggplot too, we can generate a much cleaner and better graph for our data for our reporting. So, but aside from that, you can also create interactive data or interactive kits to visualize your data using leads, and you can see that generate data that can be interactive. You can see right here. So you can generate interactive data based using our statistics themselves, which can this data can be exported into a more widget or a HTML browser to be open for data presentation and interact with data. So once you have all your results, how are you going to export it out? You can either manually just save the whole thing, just copy this whole thing like I created just now into Microsoft Windows, Microsoft Works, voila. And another one will be the graphs. I just here copy image, sorry, and here you go. So it's fairly simple and easy to use. And basically, this is how I use my R statistic programming for my work and also statistic analysis. If you like what I've shown so far, please like, subscribe, and share the video to everyone that you think it's useful for them. For now, thank you.